My name is Mark A. Allen. I am an economist and engineer by undergraduate training, and more recently am one of the primary developers of Life 365 version 2.0. We want to give credit to Evan Bentz and Michael Thomas for their initial work in the software. So Life 365 started about 10 years ago, based on a need through ACI to come up with an industry consensus service life prediction model for concrete. And over that 10-year period, it's gone through a series of committees, versions of the software, and methodologies, and now is a pretty solid tool for estimating these concrete service lives when they are subject to chloride corrosion, where chloride corrosion is the primary mechanism for corrosion of the concrete. The basic model itself includes namely specific corrosion protection strategies. So if you have a concrete slab, a concrete pier column, a tilted wall that's subject to chlorides, or other types of standard concrete members, you can assess directly what the impact on service life and life cycle cost would be of lowering the water cementitious material ratios, adding in SCMs or inhibitors or barriers, or alternate types of reinforcing, such as epoxy-coated rebar or steel. Directly in the software, in the methodology itself, you can estimate what those comparative advantages are. It also includes, for the life cycle costing, it follows the ASTM E91 standard practice for measuring life cycle costs. A lot of the discussion over the last 10 years has been about there have been limitations on using life cycle costs because there hasn't been a standard cost model, if you will, for life cycle costs of concrete structures. And we've specifically taken the task here of using as the initial standard that ASTM standard for measuring life cycle costs. It was developed through NIST and the group that I was in while I was at NIST. And it provides you a baseline model. It may not be a standard model for concrete structures themselves, but it does provide that baseline that can be used across all types of construction technologies. And then finally, the steps for determining the service life and life cycle costs of alternate concrete mixtures and protection strategies is the following. First, the methodology estimates the time required for corrosion to start on the internal reinforcing steel. It then uses some values for how long it takes for that initial corrosion to propagate to the point where the concrete structure or the concrete member really needs to be repaired. The second step is that it estimates these project costs associated with basic project costs for concrete structures, namely the construction cost, repair costs, and in particular you're looking for those costs that will vary a great deal between your alternative concrete mixtures. There's a lot of costs we purposely do not include simply because they would be the same regardless of your particular corrosion protection strategy. So what we're trying to do here, and it's standard in life cycle costing to focus on just those costs that will vary greatly. The third step is to compute the life cycle costs of these alternative concrete structures, and we'll walk through that in the software. The basic high-level view on Life 365 is that it's designed to capture components of concrete structures. For those that are familiar with the core element data set, for example, in Pontus, we're looking at specific sub-elements. In the case of bridges, we're looking at bridge decks and potentially columns if the columns are exposed to high levels of chloride. I've seen some interesting work through Hawaii where they have ambient chloride simply because they're on the ocean quite a bit. So many bridge elements will be subject to chlorides. Concrete roadways, there's a lot of work that's done with Life 365 on parking structures, in particular primarily the decks, but then also other parts of the structure that may just capture spray. The primary mechanism of corrosion in Life 365 is still chloride attack. In other words, it does not address cracks, it does not address ASR and some of the other means of attack. And the reason for this is that this is a difficult process from a research standpoint, a laboratory testing process, trying to accurately capture those effects into equations that can be run in software and a methodology is still a difficult process. So while we've done a lot in the Life365 process to come up with an industry consensus model, some of these additional factors are still not yet captured. And as such then, Life365 is still really best suited for environments where chloride attack is your primary attack. Let's walk through what the primary ones do for you in Life365 in terms of what they show you. So your overall task in terms of designing this particular concrete structure is to try to reduce the amount of salt on the structure and then reduce the speed with which the chlorides that are on the structure actually get to the reinforcing steel. And then once they're at the steel, try to increase the resistance of that reinforcing to attack. So sequentially, in terms of the chronology of an attack, if you will, the first things you can do to reduce chloride exposure is to apply sealers and barriers to your concrete structure. And in doing so, you'll see on the right-hand slide there, the red line that's pretty much a straight line. That's right, I can use my mouse. So here, the red line shows you what an unprotected slab's exposure would look like in this particular place. And we'll look at the different places you can apply the concrete. This is what it looks like when it's unprotected. When you apply a sealant or barrier, you can reduce the actual level of chlorides that are exposed directly to the concrete over time. It's as if you put a cap on a tooth and you've been able to reduce the actual level of surface layer exposure, and do this in a way so that the actual amount of chlorides that are on the concrete are reduced. And you do that through the sealers and barriers. The next thing you can do is you can lower the water cementitious material ratio and apply silica fume, both of which will reduce that initial diffusivity of chlorides through concrete. So you've made the concrete less porous at the initial level, and when it's first made and placed, things that are like the 28-day diffusivity, that number you've been able to drop down. And you'll see that here in the lower slide, where here's one that has a fairly high water cementitious material ratio. By lowering the water cementitious material ratio or adding silica fume, you can actually lower that initial value from something up here of 0.07 in the appropriate measures down to about 0.04. You've about halved the initial diffusivity, and doing that through the lower WCM and silica fume. Now, over the course of the life of the structure, here it is over time. You'll see here over time, from the initial placement through at least 40 years in this graph, there is a rate at which this diffusivity goes down, and you can speed up. The lower the diffusivity, the harder the concrete, or less, I'm sorry, not harder, the less porous it is to chlorides. So the more you can get this to decrease over time, the faster you can get it to decrease, the slower the chlorides are going to progress through the concrete. Now, the two ways you can do this through the Life365 methodology is by adding fly ash or slag to the mixture. What it does is it modifies this calculation term called M, and the higher M is, the faster this number goes down. So in this case, you're able to speed it up. In the case of this mixture here, while it's hard to see in the graph, you've been able to speed that up, that process of lowering the diffusivity. And then finally, once the chlorides reach the reinforcing steel, you can make them more resistant by requiring a higher level of chlorides, if you will. You can increase by a factor of 10 the amount of chlorides that the reinforcing can sustain by doing things like adding corrosion inhibitors, using epoxy-coated rebar, or stainless steel. And by doing that, you've made it more resistant. It can handle more chlorides before you initiate corrosion. So these are the primary sets of corrosion protection strategies that Life365 allows you to apply to your concrete mixtures.